Thank you for watching this EthicalChem Learn in Under 5 video on frequently asked questions about surfactants in remediation. Questions and concerns often associated with surfactants include: will surfactants create a runaway or mobilized contaminant? Will there be a permanent increase in groundwater concentration? And how, during an EthicalChem surfactant-enhanced in situ chemical oxidation treatment, is contaminant mobilization managed? Let's look at the answers to these questions as well as a field example. As opposed to the S-ISCO approach, conventional flushing applications apply surfactant alone in an attempt to emulsify contaminant and recapture the surfactant and contaminant through extraction wells. Although this surfactant-only approach may remove bulk phases of contaminant, it will result in some amount of emulsified material remaining in the groundwater phase. During a S-ISCO application, surfactant and oxidant are injected together as homogeneous solutions. Emulsification and oxidation occur simultaneously, and therefore destruction occurs in place before typical groundwater speeds might carry the emulsion off-site. Optimal dosing and selection of the surfactant and oxidant ensure proper destruction of emulsified contamination. Monitoring is conducted at regular intervals on and off-site, as well as near sensitive receptors. Contingency plans, such as adjusting concentrations, injecting oxidant fronts, or extraction, are developed to provide additional protection at sites with sensitive receptors. EthicalChem technologies have never required the use of a contingency plan, however, because chemicals and contaminants have always remained within the designed treatment area. Here is a field example where extensive on-site monitoring took place during a S-ISCO project. This coal tar site was located in Queens, New York, adjacent to the East River. S-ISCO was implemented with varicose surfactant and alkaline activated persulfate. Monitoring wells were sampled daily and analyzed on-site for S-ISCO parameters including interfacial tension, sodium persulfate concentration, and aqueous total petroleum hydrocarbon concentration. This on-site monitoring well shows aqueous concentrations of each analyte throughout the project. The varicose surfactant is seen in green, sodium persulfate is seen as blue, and TPH is seen in black. During the injection period, as expected, we see a strong presence of S-ISCO chemicals in this well, along with emulsified and oxidized TPH. The injection period begins with the surfactant and oxidant traveling together into this well. Toward the middle of the injection period, emulsification is occurring, as shown by the increase in TPH, and, importantly, surfactant and oxidant are both still present simultaneously in this well. Toward the end of the injection period, aqueous TPH has been oxidized and is no longer present. The oxidant and surfactant are still present simultaneously in this well. The presence of surfactant, along with the absence of TPH, indicates the soil has effectively been treated in this location. Post-injection monitoring shows no presence of S-ISCO chemicals moving through this well. This graph shows, on the same scale, collected from a well down gradient of the injection area. It can be seen that the surfactant as well as persulfate are both still present together in smaller concentrations and have effectively emulsified and oxidized TPH in this location. Post-injection monitoring again shows that no S-ISCO